Hey guys, so in today's lecture we are going to discuss braking effect in vehicle. So we will consider today a four-wheel drive. So this is a four-wheel, and suppose this is inclined at an angle alpha from the road. So vehicle is moving up. This vehicle is moving up in this direction, and it is inclined at an angle. It is moving up in this direction. It is inclined at angle alpha. Now suppose it is having a center of gravity, that is G, at this point. Now uh, it will acts the body force in downward direction, so the body force will be mg. So this is mg. Now as it is moving in this direction, so the force of acceleration will be ma in this direction, and the component of this forces will be horizontal and vertical component. So this will be mg. uh, this angle is alpha, so this will be mg sine alpha, and this will be mg cos alpha, and the distance between these two wheels is l. Now the force of friction, the friction force acting here on the contact, here it will be fa. So there is no gap here, but I have shown here there is no gap here. So this point I am calling as A, and this point as B. Now in a four-wheel drive moving vehicle, the brakes may be applied to the rear wheels only. So the brakes can be applied to rear wheels only, means this back wheels. Second, front wheels only, means this front wheels only. And third, all all the wheels. So in this mentioned three types of braking, it is required to determine the retardation of the vehicle when brakes are applied. So since the vehicle retards, therefore it is a problem of dynamics, but it may be reduced to an equivalent problem of statics by including the inertia force in the system of this forces actually applied to the vehicle. So the inertia force is equal and opposite to the braking force causing retardation. Now consider this vehicle moving up. Here the alpha is the angle of inclination of the plane to the horizontal. M is the mass of the vehicle in Newton. Then h is the height of the CG. So here we're considering this h, this distance as h. So h is height of the CG, center of gravity of the vehicle, above the road surface. Let x be the perpendicular distance from CG from the real axle. So let this distance will be x. So uh, as the car is moving in this direction, so this will be the rear axle, and this will be the front axle here. So this distance we are considering as x. Then let L, so this is the L, be the distance between this center and rear front wheel. Then RA and RB, the reactions on the ground and front and rear wheel. So here the force acting here will be RA, and this acting here will be, sorry, this I am considering RB, and this is RA. This is the front wheel, so this will be RA. Then mu is equal to coefficient of friction between tire and the road surface. So that's mu be the coefficient of friction, and A be the retardation of the vehicle. So brakes applied to rear wheel only. Let's consider different cases. So first I will consider applied to rear wheel only. So it is common way of braking vehicle in which the braking force acts to the rear wheel. So let's resolve the forces here. So if we resolve the forces here, so what are the forces? Uh, if it is applied to rear wheel only. So this is the rear wheel. So here the force of friction, that is FB, will be acted. So FB will be acted here. So here it will be, so here will be FB, and there will be also mg sine alpha. So mg sine alpha. So what will be the action of friction? So it is moving in this direction. The friction force will be in this direction. So the total force will be here friction force plus this body force mg sine alpha equal to ma. So here resolving the horizontal forces, we are getting fb plus mg sine alpha is equal to ma. Now resolving the vertical forces here. So vertical here is ra and here it is rb, and this is equal to here mg cos alpha. This is equal to here mg cos alpha. So ra plus rb is equal to mg cos alpha. Now here fb is the total braking force acting at the rear wheel, that is friction force. So fb we can write it as mu rb. So we can write here as mu rb. So so it will be, so here I can write it as mu rb. Now let's take moment. Now let's take moment at g. So let's take moment at g. So that is center of gravity here. So taking moment, we'll get that fb into h. So fb is acting in this direction, fb into h. So fb into h into x, sorry, fb into h, so, is equal to, taking moment here, we're getting fb into h plus what are other forces, rb. So rb into x, rb into x, rb into x is equal to, which force is left, ra. So ra into L minus x, total length is L, so L minus x, Ra into L minus x. So taking moment at g from left to right direction, so it is Ra into L minus x. So here we'll put fb is equal to mu rb, so we'll get mu rb h plus rb x is equal to Ra. So instead of Ra we can write here what we can write instead of Ra. So if I want to make a subject of Ra here, so Ra I can write here is mg cos alpha minus rb. So here you can see that I am substituting every term in terms of rb. So it's to find rb, so mg cos alpha minus rb into L minus x. Now let's open the bracket and take rb as a common here. So what we'll get here, that is rb is equal to mu h plus x. So it is mu h plus x is equal to mg cos alpha, mg cos alpha into L minus x minus rb into L minus x. Now if I take this rb on this side, so what I will get is rb into mu h plus x plus L minus x. So you can see the x gets cancelled here. On the right hand side I am getting mg cos alpha into L minus x. So rb, if I take this term on the denominator side, so I am getting rb to mg cos alpha L minus x divided by here mu h plus L. This is the value of RB. So similarly, if I want to find the value of RA by substituting the value of RB, so I know that mg cos alpha minus RB is RA. So it will be mg cos alpha minus, if I put the value of RB here, mg cos alpha into L minus x divided by mu h plus L. So here I will get mg cos alpha into mu h plus L minus L plus x. So L gets cancelled. So I'm left with mu h plus x divided by L plus mu h. So RA I have got is at mg cos alpha into mu h plus x divided by L plus mu h. Now we have got the value of reaction forces RA and RB. So the difference here it is L minus x and here it is mu h plus x. Now we have this equation that FB. So here we have this equation FB plus mg sin alpha is equal to ma. Now if I want to find the here acceleration, so I'll make A as a subject. So what I will get here, so I'll just rewrite the equation here, FB plus mg sin alpha is equal to ma. So if I make A the subject, so A will be subject will be FB plus mg sin alpha divided by m. So acceleration A is equal to FB by m plus g sin alpha. So acceleration will be equal to mu RB. As you know, the friction force is mu RB divided by m plus g sin alpha. So putting up the value of RB in this equation, we will get A mu by m into mg cos alpha L minus x divided by L plus mu h plus g sin alpha. So acceleration A is equal to here, if I take this, gets cancelled here, so I'm left with here mu g cos alpha into L minus x divided by L plus mu h plus g sin alpha. Now on a road level where alpha is equal to 0, so when alpha is equal to 0, so acceleration will be equal to mu g into L minus x divided by L plus mu h. The sin alpha is 0, sin 0 is 1. So when vehicle moves down the plane, so becomes FB minus sin, so FB minus mg sin alpha is equal to ma. So at that time acceleration A will be equal to FB by m minus g sin alpha. So this equation here will become just here a negative sign, plus or minus, if it is moving down the plane. So similarly, you can find when applied to the front of the wheel, brakes applied to the front of wheel. Now we will discuss brakes applied to all four wheels. So if it is brake is applied to all four wheels. Second case you can discuss on your own. Now third case, that is applied, it is similar to the first one only, applied to all four wheels. So Fa, that is friction force, and Fb, that is friction force on front wheel and rear wheel. This both will act. So the equation will be Fa plus Fb plus mg sin alpha is equal to ma, and here it will be Ra plus Rb is equal to mg cos alpha. So here same case, that Fa plus Fb, if I take a moment at g, so it will be Fa plus Fb into h plus Rb into x is equal to Ra into L minus x. So same process we are repeating here. So here taking moment at center of gravity g, so there are two forces, friction force, it will be distance h, and reaction force Rb and Ra here. So now putting the values of coefficient of friction here, so it will be mu Ra plus mu Rb into h plus, here instead of Rb I can write here mg cos alpha minus Ra into x is equal to Ra into L minus x. So here similarly, so mu is here common, so I can take mu as a common here, so I can take mu into Ra plus, instead of Rb I can write this equation again, it is mg cos alpha minus Ra. So Ra will get cancelled here, so here it will be h plus mg cos alpha minus Ra into x is equal to Ra into L minus x. So Ra is equal to mg cos alpha into mu h plus x divided by L. So if I make R as a subject, so I will get here that mu so if I make here R as a subject, so you can see that here mu h into mg cos alpha, and here mg cos alpha into x. So mg cos alpha is constant, so mu h plus x comes out, and here Ra into x is minus. If I bring on the right hand side, so I'll get here Ra L minus x plus x, so x get cancelled, so I'm left with L. So Ra into L, so L will come in denominator, so we got the value of Ra here. Similarly, we can find the value of Rb, so that is Rb is nothing but mg cos alpha minus Ra. So Rb will be equal to mg cos alpha into L minus mu h minus x divided by L. So and similarly we can find the value of acceleration from the equation, that is Fa plus Fb plus mg sin alpha is equal to ma. So mu Ra plus Rb, so mu Ra plus Rb plus mg sin alpha is equal to ma. So mu mg cos alpha plus mg sin alpha is equal to ma. So A will be equal to g mu cos alpha plus sin alpha. So now on the road level where alpha is equal to 0, so when alpha is equal to 0, Ra will be equal to mg mu h plus x divided by L. Rb will be equal to mg L minus mu h minus x divided by L, and A will be equal to g into mu. So this is the value when road level is 0. So if the vehicle moves down the plane, then the value will be negative here. So if it is moving down the plane, so here acceleration will be negative here, uh, and RA and RB will also uh, will so only the acceleration will be here negative. So this is the formula for when the brake is applied to the front wheel or the rear wheel or both the front and rear axle at the same time. So I hope you understood. Now see you in the next lecture. So thank you very much.